more. We're going to use different method. This method is called conjugate method. And yeah, let's start. First thing, reactions all the time. 20 going down. And the distance here and here are equal. And they are all equal. So we don't have to do any calculation and we can find the reaction, which is 20 and 20. After that, share moment diagram. So this one, 20 going down, 20, so it's negative 20. Nothing, go straight, hit the 20, go up to 0. Nothing, just keep going, keep going, keep going. 20 going up, nothing. So 20 going up, going up, going up, going up. Go down, touch 0. Here is 6, here is 6, here is 12. That is shear. So moment. This is shear. This is moment. We're gonna have something like moment. You calculate this area, 6 times negative 20, so you're going to have negative number. So you know this is just a overhang, so it's no slope, so start from 0. At this point, you're going to have 6 times negative 20, so negative 120. Nothing in between, so just straight line at this point. Positive 20 times 6, so it's positive 120, so go up and hit 0. That is your movement. So now, let's draw it on this side. You know what? I think you just hold it.
No, just not all the way to the right, that's all.
Something like that. So now, conjugated method.
Why did you put a positive sign? Isn't that negative? On the moment.
Oh. So this one, the conjugate method tells you when you see a free member, you need to make this as fixed. So you're going to have fixed, and you see internal pin and internal roller, you change it to a hinge. Is that even? No. Again, this is a free member or beam or member. You have to make it fixed.
This is a deflection diagram, right?
There's no deflection thing. We don't do
Oh, this
deflection.
is the conjugate method diagram.
Yes. So that's what we have. And look at the moment diagram. At this point, we have negative 120. So at this point, you're going to have negative 120 over EI. 1 EI. Because the question gives you this part is 1 EI, this part is 2 EI, and this part is 1 EI. So this, just the first part. So it's 1 EI. Same thing here. This line is negative 120. Everything is negative 120 at this line. So this one, you're going to have negative 120 divided by 2 EI. Because this distance is 2 EI. That's what the question said. So this one, same thing, negative 120 over EI. Before, we have just a point load. So we don't have, when we fix it to, when we transfer this to conjugated method, this one you don't have to write down the moment and share. So just leave it like that. This one is a hinge, but before we have, no, that's hinge. So now we have to find, but before it's a support, so we have to find force for this too. So we're gonna have force for this thing. So how are we going to do it? So first thing, we cut it open. And separate like this.
Lee, you said wherever the supports are, that's where you build, you put a hinge?
What?
The triangle is at the hinge.
Yeah.
Oh, really?
Yeah.
Oh shit. So I hate drawing this. Should I? Okay, no.
Mohammed, can you please pay attention?
We make a cut and we made a cut. So we're gonna have all these things is 91.0 over, yeah. This is we make a cut. We have that. And have that. Because this is a negative moment, so for the arrow, you have to point it down, away from the beam. So it's going to be negative, 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 like this. So when we make a cut, because this is a hinge, you make a cut, you know you're going to have two force, and before you have support, so like, you're going to have two force. Going down, because you made a cut, if this is going down, this is going up, this is going down. This one's going up, this one's going down.
Everything is distributed?
Yeah.
Distributed.
Mm-hmm. And for this one, it's negative 20 divided by 2 EI. This one is negative 120 over EI. Like I told you before, we have two support, but we transfer it to a hinge, but we still have to find force for this too. So we're going to have, and support is right here. So we're going to find this. How are we going to do that? We take this area, which is 120 divided by 2 EI, times the length. This is 12 feet, 6 feet, and 6 feet. So for this one, just take this times that, length times height. So negative 20, 2 EI times 12. When you do that, you know this is a distributed load. You do that, you're going to find a point load. A thing like this. And this is this. After you find a point load, this one is equal to, please divide by that. So it's 144 divided by 2 EI.